Okay, let's get into this. It's kind of strange when you think about it, right? Computers run on zeros and ones. Super precise, deterministic.
Totally predictable.
Exactly, but then you have human language. It's messy,
Hmm.
full of nuance, context. It's just not precise like that.
It's fundamentally probabilistic, not deterministic. And that difference, that kind of clash, is really what Ash digs into in his series.
Right. He takes us on this journey from traditional computing into how AI, specifically these large language models, tries to handle meaning and language.
Yeah, and it's a really great way to understand it because he builds it up piece by piece, starting with the absolute basics.
So that's our plan here. Really unpack Ash's view, understand that huge shift from rules to probability, and see how it all connects to what these AI models can do now, and maybe pick up on some of his wry comments along the way.
Absolutely. He's got a distinctive voice.
Yeah.
So whether you're prepping for a meeting or just, curious, we want to give you that core understanding Ash lays out without getting lost in the weeds.
Okay, so where does Ash start? The bit, right?
Yep, the absolute fundamental, the 0-1, true or false. He really hammers home that this is the bedrock of traditional computing.
And because of that, traditional software is deterministic. You put something in, you know exactly what you'll get out.
Like a calculator.
Yeah.
2 plus 2 have to be 4, every single time. Or an ATM giving you the right cash. You need that certainty.
Definitely need it.
But, and this is Ash's key point early on, you just can't write rules for everything. Reality, especially language, is way too complex.
How would you even start writing rules for understanding irony or sarcasm or just context?
Exactly. So that's why AI takes a different route. Learning from data, finding patterns, sort of like our brains do, instead of just following explicit instructions.
Which leads to what Ash calls the big shift, moving away from deterministic.
To probabilistic or stochastic, he uses that term too. It's the complete opposite, really.
Because these LLMs, they aren't following a rule that says, after these words, say this word. They're guessing.
But essentially, yeah. Calculating probabilities based on all the text they've seen. What's the most likely next word? You say, the cat sounds...
Maybe proof or lap.
Right. The model calculates the odds for each possibility. It's not a fixed rule.
And Ash connects this to Turing, right? The whole Turing test idea.
He does. He notes that maybe, just maybe, with today's chatbots, we're getting close to passing that test of conversational ability. And he throws in a little aside about Turing also thinking about determinism and free will.
Ah, yeah, the philosophical bit.
Which Ash says is for another day. But it shows how these technical ideas can branch out.
Okay, so if we're moving beyond strict rules, how do these machines represent something as fuzzy as meaning?
Well, Ash builds this up really nicely. He starts simple, numbers on a line. That's one dimension, 1D.
Okay, simple enough.
Then he uses geometry. Add another axis, you get a 2D plane, like graph paper. Add a third, you get 3D space. Points in these spaces can represent things, and the distance between points starts to matter.
Right, coordinates on a map, for instance.
Exactly. And geometry and algebra, Ash reminds us, are just different ways of talking about the same relationships.
But then he makes this leap, right, beyond 3D.
Yeah, and this is where Ash says it gets really interesting. We can't picture more than 3 dimensions, but mathematically, computationally, no problem. Computers can handle hundreds, maybe thousands of dimensions.
Thousands? Why on earth would you need that many?
Because, and Ash frames this almost philosophically,
Yeah.
the meaning of anything is incredibly complex. Think of all the connotations, implications, nuances of even a simple word. Capturing all that richness computationally needs a very high-dimensional space.
Okay. So this space is what he calls semantic space.
Exactly, semantic space. And the absolute core idea Ash presents is that meaning isn't just a point. It's about the distance between points. Things with similar meanings cluster together.
Ah, okay. Can you give an example? Like the ones Ash uses.
Sure. His Apple example is great. Apple, the fruit, and Apple, the tech company, are the same word, but they mean different things. So in semantic space, they'd be at slightly different points, reflecting their different contexts and associations.
Makes sense.
Or think cat and dog. They're closer together in semantic space than, say, cat and car, because semantically, they're more related. A basic dictionary app just sees letters, right? C-A-T.
Right. It doesn't get that cats and dogs are both animals.
But the semantic space representation does capture that relationship through proximity. Ash really emphasizes that words are just symbols, tools we invented. Meaning is deeper. LLMs try to capture that depth.
And this isn't just for single words.
No, it extends to phrases, sentences, whole documents. That's how things like recommendation engines can work, finding items or articles that are semantically close to what you liked before.
Okay, that mapping of meaning feels central. And it connects back to that structure idea, doesn't it?
It does. Ash brings us back to the hardware, the transistor, the binary state demanding precision. And that flows into how computer code has to be written.
Yeah, he has that funny bit about code being rigid. Miss one comma.
Heh, boom. Disaster. He calls programming a high art and a costly skill. And programmers a weird bunch, the geeks, nerds, techies. Maybe a little poke at himself there.
Could be. And it's not just the code, it's the data, too, right? Needs structure.
Absolutely. Spreadsheets, databases. Ash points out we use structured data all the time, like filling in an online form with a specific format for your phone number.
So structure gives you that certainty, feeding the deterministic side.
Right. But then Ash asks this great question. Why should we always have to fit our information into the machine's rigid boxes? Shouldn't computers learn to deal with our messy reality?
And AI is supposed to be the answer, handling unstructured data.
That's the idea. Emails, articles, conversations, most real-world data isn't in neat rows and columns. AI, mimicking us, should be better at handling that.
So people are using AI to analyze all that unstructured stuff.
Yeah, either trying to turn it into structured data or using AI to work with it directly. But Ash injects some realism here.
Oh, how so?
He notes it hasn't been some magic fix, not as easy as some lazily expected. You can't just throw AI at a pile of documents and expect miracles. We still need the structured systems, and we're still figuring out the best way to combine AI with traditional software.
Okay, so that brings us to how these LLMs actually work when we interact with them, like using a chatbot.
Right. When you type something, that text goes to the model, like GPT-4 or whatever. That whole process of the model computing a response, that's called inference.
Inference. Got it. And Ash highlights something key about inference. Statelessness.
Exactly. It's fundamentally stateless. Each time you send something, it's like a brand new interaction. The model itself has no memory of what you just said 5 seconds ago.
Chatbots do seem to remember the conversation. How does that work?
Ah, that's a clever trick, Ash points out. It's the interface, the chatbot application you're using. It takes the last few turns of your conversation and bundles them up with your new question.
And sends it all back to the model.
Yep. Feeds it back in its context. So the model sees the recent history, but only because the interface manually provides it. And there's a limit to the context window. It can only handle so much past conversation.
Okay, that makes sense. But what if I wanted to know stuff it wasn't trained on? Like my company's internal reports. Fine-tuning used to be the way.
Yeah, but as Ash notes, fine-tuning is expensive, complex, and not great for data that changes all the time.
So what's the newer solution?
RAG, retrieval-augmented generation. This is where that semantic space idea comes back in a big way.
Okay, how does RAG?
You take your specific documents, emails, reports, whatever, and you process them. You turn chunks of that text into numerical representations.
Beddings, vectors, using semantic space.
Exactly. Those embeddings capture the meaning.
Yeah.
Then you store them in a special kind of database called a vector store.
Okay, got the embeddings in the vector store. Then what?
Then, when you ask a question during inference, the system first does a quick search in that vector store. It looks for embeddings that are semantically closest to your question.
Using that distance idea again, finding relevant stuff.
Right. It retrieves the chunks of text linked to those close embeddings and adds them to the input it sends the LLM right alongside your actual prompt.
Ah, so it gives the LLM specific relevant information just in time for answering that question.
Precisely. It grounds the model in your specific data without needing full retraining. Ash uses this memorable, it's slightly morbid analogy about taking a slice of Einstein's brain to consult on a specific physics problem. You're retrieving just the relevant knowledge slice.
Okay, that's vivid. And Ash also points out that chatbots aren't the only way to use this.
No, not at all. Businesses are wiring LLMs and RAG systems directly into their own software, using APIs for all sorts of internal tasks.
Which leads to, how do we talk to these things effectively? Ash has a joke about this, doesn't he?
He does. The stingy genie joke. Someone wishes for $1 million, and the genie gives them $1 million Zimbabwean dollars. Technically correct, but useless.
Right, because you weren't specific enough.
Exactly. So, guiding the LLM, getting it to give you what you actually need rather than just the most probable next word that's prompting, and Ash says it's definitely more art than science right now.
The prompt engineer, that new job title you hear about.
Yep. Because, as Ash emphasizes, human language is just packed with ambiguity, assumptions, stuff we don't explicitly say. Making prompts that work reliably is tricky.
He suggests trying an experiment, right? Asking the same open question twice.
Yeah, ask something like, tell me about space exploration in one chat, then start a totally new chat and ask the exact same thing. You'll probably get different answers, which is fine for casual use, but tricky for professional applications needing consistency.
It really shows they're machines despite sounding human sometimes. They lack that common sense, that lived experience Ash talks about.
Totally. And that lack of grounding, combined with the probabilistic nature, leads to some of the quirks like hallucination. Back to the, are they just parrots question.
Ash seems kind of amazed that next word prediction works as well as it does. Right?
He does. He
Mhm.
finds it miraculous that it produces coherent text, but he also flags the questions. How does it stay on track? How can one bad prediction derail it? How does complex reasoning emerge?
And that's where hallucination comes in. The model just makes stuff up.
Confidently make stuff up, yeah.
Yeah.
Ash is clear. It's not like human hallucination. It's more like the probability calculation goes a bit sideways, picking lower probability words that lead it down a nonsensical or factually wrong path.
But then Ash asks that provocative question. Don't humans kind of do that too sometimes with our own unpredictable language?
He does push that a bit, and it connects to the really thorny issue of bias.
Uh-oh. How does he handle that?
He poses it as a challenge. How can we demand unbiased AI when we humans can't even agree on what bias is? He uses political divides as an example. Each side sees the other as biased.
So his take is,
He suggests maybe being a bit forgiving about bias and LLMs on subjective topics where there's no human consensus anyway. But he does acknowledge hallucination happens with facts too, often due to gaps in data or context. RAG and good prompting help, but it's still a challenge.
okay, so given these capabilities and quirks, how are businesses actually using this stuff?
Well, Ash sees LLMs as genuinely revolutionary tech, opening doors everywhere language is involved.
But using it in a business setting, B2B, is different from just playing with a chatbot, B2C.
Definitely. There are extra considerations. One technical concept Ash introduces is temperature.
Temperature, like heat.
Sort of. Think of it like a dial for creativity versus consistency. Low temperature forces the model to stick to the most likely words. Very consistent, maybe a bit boring.
Conservative output.
Exactly. High temperature lets it explore less likely word choices, more creative, potentially more surprising, but also less predictable, more risk of going off the rails.
And businesses usually want.
Low temperature. Consistency, reliability, sticking to facts, following quality standards. You don't want your support bot getting wildly creative with solutions. Maybe for writing fiction, high temp is fun, but not for professional use cases, Ash highlights.
Makes sense. And these enterprise setups aren't just chatbots usually.
No, typically they involve custom software, integrating the company's own data, using RAG, APIs. It's more complex.
Which brings up testing. How do you test this stuff?
Huge challenge, Ag points out. Testing normal software is straightforward because it's deterministic. Input A always gives output B. You test 2 plus 2 must be 4. You find bugs that way.
But LLMs aren't deterministic.
Exactly. And they output human language. Tokyo is Japan's capital?
Mm-hmm.
The same as the capital of Japan is Tokyo?
Mm.
To us, yes.
Mm.
To a simple string comparison test, no.
So traditional testing doesn't work well.
Right. This new challenge is called evaluations, or evals.
Mm.
And Ash stresses it's a super new, cutting-edge area because using LMs this way is still pretty recent.
Ash has that clothing store example that ties a lot of this together.
Yeah, it's a great end-to-end illustration. You start with structured data, the store's product list.
Then someone asks something unstructured, like, I need clothes for a vacation in December.
The AI uses semantic understanding. December means winter. Vacation means travel. It bridges the user's need to the product data.
Harbag kicks in, pulls info about winter coats or travel wear from the vector store.
Exactly, based on semantic nearness. Then prompt engineering structures the query for the LLM, including conversation history, because inference is stateless.
And hallucination is a risk, like it inventing a solar-powered scarf.
Precisely. If our guy fails or the prompt is bad, it might make up products. Bad for business.
And this example really shows why evals are hard. It's not just facts.
Right. Ash uses examples like asking for a minimalist aesthetic, or clothes for an outdoor wedding in New England in October, or making a wardrobe more sustainable.
Evaluating those answers, wow, you need to judge style, appropriateness, sensitivity, brand alignment.
It's way beyond just checking if a fact is right or wrong. It requires nuanced human judgment. And figuring out how to do that systematically and scalably is the core challenge of evals.
Okay, so stepping back, let's recap Ash's journey for us.
Sure, he really contrasts conventional software rules-based, deterministic, with AI neural nets, emergent behavior, probabilistic.
We saw how information gets represented, from the simple bit up through dimensions into that high-dimensional semantic space where closeness equals meaning.
Explore data handling, the traditional need for structure versus AI's ability to tackle unstructured data using things like embeddings and vector stores.
Looked at the tools. RAG, the core next word prediction refined by RLHF, and the human art of prompt engineering.
And face the challenges. Hallucination, the complexities of bias, and the tough problem of evaluations, or evals.
It's a really comprehensive picture Ash paints. And his style, mixing the tech with relatable examples and those slightly irreverent comments.
Like a high priesthood of programmers. Yeah,
Cute.
it makes it very accessible, I think.
It really is amazing how far things have come in getting machines to handle language, bridging that gap between the zeros and ones and, well, us.
Absolutely. But Ash's work also makes it clear we're still figuring things out. Dealing with hallucinations, making RAG better, mastering prompting, building good evals, tons of work still happening.
And thinking about Ash's points on ambiguity, bias, how hard it is to evaluate fuzzy, non-deterministic output, it makes you wonder, doesn't it?
How so?
Well, if human meaning itself is often subjective and context-dependent, and these AIs kind of reflect that probabilistic nature, how much certainty can we actually expect from them? What does perfect truth even look like in language?
That's a deep question. It almost forces us to examine how we evaluate information and handle ambiguity ourselves.
Or remember Ash mentioning Turing and free will? If deterministic machines felt like they clashed with free will, what does a probabilistic machine tell us about our own thinking? Are we just complex prediction engines?
Whoa. Definitely some powerful ideas to chew on there. As Ash puts it at the end of his series, are you, the listener, ready for what comes next?
We definitely encourage you to keep exploring, keep thinking critically about all this.
Thanks for diving deep with us today.